My name is Ling, and I would like to talk about app development today. So that's all my Japanese. I will switch to English.
My name is Ling, or you can call me Wei. I'm from Line Taiwan, and today I would like to share you some of our team's learning of how we continuously deliver our app with high agility and high quality. In the beginning, I would like to introduce myself. I'm in Line Taiwan's app team, and currently I'm working on 4 different app projects: Line app, Line Today app, Line SDK, and Line Music app. I also joined iOS app development in Line. Today, I would like to share how our team designed the best practice to fast and deliver our app with high quality, and we also can reach our market faster and receive feedback quickly for our developer team. I hope after you listen to this sharing, it may help you or your team as well. Line to the app is a multimedia app in iOS and Android that features news, entertainment, movie, video, and personalization. It's a global project and a joint effort of Line Taiwan app team and the Line Indonesia app team. We developed this Line to the app to provide more native user experience for our Indonesian users. And in addition, we would like to spread this experience to other market in the world as well. Before I jump to my main topic today, I would like to play a quick puzzle game, and I always call it a CI/CD puzzle for app development. And I believe most of you already have your own CI/CD pipeline to achieve quick feedback to your developers and also maintain your app's quality. To us, we also want to fill all the blanket to make sure our app to have a good CI/CD pipeline. So for our team, in Line, every code they send their pull request need to pass peer code review. During code review, our CI/CD system will run unit tests and integration tests to make sure our code is healthy. Only the code that passed code review, unit tests, and the integration tests can be merged into our master branch. So we have a healthy build that we can move to the right side. We will use the new build to run our UI automation test. We have a device tab that has multiple iPhone and Android devices that run parallel UI automation testing on different iOS and Android versions. The build that passed our UI automation test can now be deployed internally for further check by our product owners, developers, or test engineers. Before every release, we also need to do external deployment. And as many of you already know, we need to deploy our iOS app to Apple TestFlight. And for the Android, we need to deploy to our Google Play Store. And then our team will do a quickly check using exploratory test to explore our app to see any unexpected issues. If all the checks are passed, we know our app is ready to be released. And most importantly, in this CI/CD process, we need to make most of the process automation because that will give us quick feedback. And then our team will fix it quickly and also maintain the quality. So I believe most of you are already familiar with CI/CD automation. This all blue area are automation. So if we want, we can start after the code merge, we can all the way to the Explorer deployment if we are using our CI/CD automation pipeline. And both iOS and Android provide command line tools that we can automate CI/CD process. And we tend to use the default tool provided by iOS and Android because it's reliable. I think it's good enough to use. For example, in order to build and run our iOS app and the unit test, for iOS, we can use Xcode build command line tool. And for the Android, we can use the Gradle wrapper command line tool to build and run our Android app, run our unit test on Android. For the UI automation test, both Xcode build and the Gradle wrapper command line provide useful way that you can set out to run your UI automation testing on different iPhone or Android devices. As mentioned before, in our office, we have a device that's doing this task. For the internal deployment, Line has an internal deployment platform, so we can use the script to do that. And for the external deployment, For iOS, there's a useful tool called Fastend that you can use to upload your app to Apple TestFlight. And for Android, there's also a useful API tool that you can use to upload your app to Google Play Store. I believe most of you already know this process, and you are doing your own CI/CD process according to your team's need. Everything you're doing is slightly different according to your team's resources or project need. Today, I would like to talk a little more deeper about two main areas in this CI/CD pipeline, which are unit test and UI test. Why these two areas are important and why you should know? Because during our development for line to the app, although most of our team members know how to make an automated CI/CD pipeline, and we know how to write unit and UI tests, but there are two questions that keep us want to search best answers for our team. Which, for the unit test, what is good code coverage to have for iOS and app development? And for the UI test, how to have a stable and reliable UI automation test. We all know how to write a unit test, but when we have a large app project, I have 10 more app developers working on it, things become more complex. Then your manager may ask to have a higher code coverage to make sure you have a good code quality in every code change. Then the question is, what is the good code coverage? Like 100% code coverage? But is that possible? And what obstacle will our team have? There's no test will give us an answer, especially in app development. We need to define our code coverage for our team. On the other hand, UI automation testing seems to me amazing because it simulates the actual user scenario. But I believe you are writing your test, you might have test it pass this time, but fail next time, even you didn't change any code, which is the notorious flaky test. If we don't have a stable and reliable UI automation test, it will not help your team, it will only waste your team time. In theory, UI test is good, but it's not as simple as it may seem. We need to have a stable and reliable UI automation test, so it can really give us quick feedback. Today, in order to answer the questions, I would like to introduce our team's UI automation test guideline. All our app developers need to follow this guideline to write UI test. And second, we'll share our learning of our unit test and code coverage. The two agendas have some kind of dependency between each other. I will explain more later. If you've been to a conference talking about automation, I bet you've seen this test pyramid many, many times. It's so important, so I still need to display here again. It's the fundamental principle that we should all follow. Brief speaking, we should have more unit tests because it runs fast, can give us quick feedback. And the integration tests help us to verify the interactions among our modules. We should put less resources on UI automation test because it takes longer time to run and it has so many different dependencies that make it easily to be flaky. We all need to remember flaky tests are worse than no test. This testing pyramid is very, very important. I will get back to it later. Based on this pyramid, our team designed a testing spectrum for app development. We put more resources on the left side and put less on the right side. And the left side is more like the unit testing field, and for the right side, it's more the end-to-end testing field. In unit tests, first, our team needs to have a good app architecture to separate our logic and the UI. The good use of test double, like stop, mock, and fake object, or the good use of TDD will be really helpful for your team to write unit tests. Next, for the integration test, you need to take care of the testing like automation API testing. For the UI test, our team used for iOS XCUI test framework to write iOS UI test. And for the Android, we use Espresso and the UI automation framework to write our UI test for Android. As I mentioned before, we have the device lab to run parallel UI automation testing. And this test spectrum, more importantly, it separates automation and manual testing clearly. We still need manual testing because it can cover the things that automation cannot cover. We use the concept called agile testing to test our app more efficiently. And we also use exploratory testing to explore our app to see if there are any unexpected issue. There are many things I could share from this testing spectrum, but because of the time limit, our code coverage strategy and UI automation test guideline are my main topic today. So for the UI automation test, if you are writing UI tests, I believe most of us need to deal with the flaky test. If your team are writing UI tests and it has no flaky tests, it runs well, congratulations and please keep your great work. But if you try to write UI tests but you have so many flaky tests that make you stop writing and you don't want to put it into your CI/CD pipeline, then I believe you are the target audience for this session. Why flaky tests are so bad for your team? Maybe some of you already know, but I will quickly review it. When we start to write UI tests for both iOS or Android, use the native test frameworks, as developers, we want to write as many UI tests as we can to verify our code. So imagine we write 3 tests, test A, B, and C. And we run our UI tests on Jenkins. So first time, all 3 tests are passed, and Jenkins result will be green light. And we feel really good about it. However, when you run the second time, something strange happened. You didn't change any code, but your test A and C failed. So how about let's run the test for 10 times to see what will happen. And now you got this result. Only the first time and 5th time all tests pass, and your Jenkins will be green light, but rest of the result are all red lights, which means failed. Now, can you tell me what will happen in your 10th run? To be honest, we don't know, because we have flaky tests like test A and test C. But the things we know now is your Jenkins result will be highly likely failed because of the flaky test. And our developers need to spend their time to keep checking it. This example only has 3 test cases. What if your project has 100 more UI tests? And then you didn't fix your flaky test, and you always have red light in Jenkins result, and you just really waste your time to check unstable and unreliable tests. To us, red light in Jenkins is useless for your team. And also, this flaky test result will cause 3 really bad outcomes. First, you need to spend your time to fixing your flaky test instead of writing your feature code. What's worse, you don't want to write any new UI test. Second, you cannot put this UI test in your CI/CD pipeline because it's unstable and unreliable. Your team cannot use this result to decide whether your app is ready to be released or not. Last but not least, your team will lose confidence on UI tests and turn back to the traditional manual testing, which, as we know, is consuming and slow your team down. So we need to keep remember what test pyramid told us. We want to have UI tests. However, it's easy to develop but expensive to maintain. UI automation tests need special care to really help your team instead ruin all your team's effort. And reasons that cause UI automation tests be so flaky can be various. I believe most of the reason is because it's vulnerable nature. Here, I list all the flaky factors that I know, but I believe there will be more. Let's start from the left side. I list some internal flaky factors. It happens because your app design or your team's communication. First and foremost, our UI may change in every release. So your team needs to have a good communication to make sure your UI tests keep up to date with your new UI code. And most of the time, the app developer who wrote the current UI test and the app developer who is going to write new UI code are different. So make sure your team keep syncing the UI test before you merge any new UI code. Then I would like to talk about test environment and test data. If your team don't have stable test environment, for example, like your beta API response keep failing in a period of time, or your beta database keep cleaning out data and losing test data, then your team won't be able to have a stable UI automation test. Make sure you have a good communication with your team members to set out the stable test environment and test data, especially with your server-side developers. Dynamic element design is another issue for line to the app, because line to the app, as I mentioned before, is a content a multimedia app. So today it may provide you users news contents, but tomorrow it may provide video content to users. So the content will be changed differently every day. So we need to design our UI tests carefully and take that into account to write our code. Otherwise, our test case will be always flaky because contents keep changing. One useful solution is you inject data into your client database to make sure before running any test cases, it will set out the correct data for your UI automation test. Both XKUI tests and Android Espresso provide that tool. You can use that. Finally, poor return test code is another issue because maybe in your team, not every your team members have experience to write UI automation test. So if your team members write test cases, that depends on the result of the other test cases. Then the first test case fail, then the second test will definitely fail anyway. So make sure your team have a guideline to help your team members to write useful test cases. Let's move to the right side, that we have other flaky factors that may be out of our control. First and foremost reason is there are some known issues of XUI tests and espressos. Maybe some of you may come across some strange behavior when you run your automation tests on both iOS and Android, and it's inevitable. So most of the time we need to Google if there's some useful workaround, like for example, like from Stack Overflow, to work around of these issues. Different device dependency may happen in Android UI tests, because as you know, Android has so many different manufacturers. We have Sony, Samsung, Huawei, or Google. Then their devices may have some different behavior in some ways. And most importantly, their browsers also have different behaviors. So you also need to take care of that if you want to run parallel testing on different devices. Cross-app testing is another issue because if your app has some interaction to other third-party app, and you cannot control third-party app. So if the third-party app have some unexpected behavior, you also will have flaky test. So make sure you think twice if you really want to add cross-app testing into your UI test. Parallel testing sometimes would be unstable due to iOS or Android framework issues, but fortunately, it's not happening often. So reset or restart your iOS or Android devices could solve this issue. Finally, when we finish writing our test code, then we will use IDE, for example, or you'll use Xcode or Android Studio to check our UI tests always pass. So we will submit our code. But sometimes, even your test code pass in IDE run, it may fail in command line run, because there's some different behavior between IDE run and command line runs. So make sure after you finish your test code, not only run in IDE, but also run in command line to make sure you are not missing any flaky factors of your test code. So beware of all of those flaky factors when you are writing your test. It's really expensive to write. But if you write it well, it will really help your team and make sure you will have a quick feedback and fix issue quickly. To us, UI automation test is more like a smoking test level, that it goes through the most important usage scenario of our app. And we don't make every test into UI test. We need to remember what testing pyramid told us. So next question is how our team decide what kind of test case it can be our UI automation test. Maybe some of you already heard about this concept, but our team used acceptance criteria to decide what to write for our UI automation test. In our team, every new feature needs to have acceptance criteria. It describes the most wanted thing from our product owner. So here's the example. We have a new search page features, and that user can use this page to type keyword and search the content. And the page will have like search bar. The user can type the search keyword, filter tabs that user can switch tabs between like most rotated content or the latest content. Then we will need to display search results. And then our team will discuss with our product owner, and then we will generate 3 acceptance criteria. For example, we may have like acceptance criteria we need to display search results, or we need to have let the user can switch the search tabs to change between the most related content or the latest content. Finally, we also need that can that user to click one of the search results and display the content page. And the format for acceptance criteria can be various. Our team use BDD format to write our acceptance criteria. It contains 3 elements: a given, the precondition, when, the user action, and then the search result. By using this BDD format for acceptance criteria, it not only becomes the high-level spec for our feature development, and we can also use this to generate our manual test cases. More importantly, we use that for our UI automation test. So this is an actual example. When we have a acceptance criteria that we need to test our show search result, then we will apply this BDD format into our test code. So you can see here there's a test suite layer that it describes the test flow. And then according to our BDD format, we have a given that we need to navigate to search page from our main page. And then it will simulate user behavior to type search keyword and then tap search button. And we will have a len that we assert search result. And we use page object pattern to form our UI test in both iOS or Android because it's simple enough to maintain, and I think it's easy to understand. And the detailed element will be defined in each pages. For example, like here, we will have main page and search page. There's another benefit to use this BDD format to write our test code because it makes our test cases small and simple. So it will be really helpful for our team to isolate issues when these test cases failed. And of course, not all the acceptance criteria can be automation. So we also have a guideline for our team to make a decision what kind of cases can be automation and what kind of cases should still remain in manual regression test. For example, on the left side, if we have acceptance criteria that we know is the most common and the most important user scenario of our app, and it's a mature functionality, which means we know the feature is not going to change in short time, then the flow is also suitable to automate. Then we will make it into our UI automation test. However, if we have a case that we know the features is going to keep changing, for example, due to our business plan, or we will have like phase 1 and phase 2 features, and the feature will not be the same, then we won't rush to put into our UI automation test. Or maybe we will have other cases that it's hard, it's not easy, and you need to put a lot of resources to make it automate. Then it will still remain into our manual regression test. For example, like app push notification. Finally, this is the result of our team adapting our UI automation test guideline. And let's see from the left side, we will have 2 lines. One is yellow line and green line. Yellow line is our manual regression test numbers, and it's an aggregate number of our test cases in different environment and different devices. For example, one test case may need to run 4 times on different iPhone or Android devices. And the green line is our UI automation test ratio. It means how many test cases are covered by our UI automation test. So you can see on the bottom, it describes our app versions. So before our app version 3.3, our UI automation test ratio was quite low because we were suffering from flaky test. And we don't want to add any new UI automation test. So most of the time, we need to rely on our manual regression test. And you can see before the app version 3.3, we reached the peak of 1,500 test cases, manual regression test, because we will have like more new features and more new test cases coming before every release. After we start adapting our UI automation test guideline, start from our version 3.4, which is the blue area. Our UI automation test ratio start to rise because we can have a more stable and reliable UI automation test. So we can write more, and then some of the test cases can be covered by our UI test. We don't need to do more on our manual regression test. As a result, our manual regression tests start to drop, even we still have new features and new test cases coming before release. The last three versions, 3.7, 3.8, and 3.9, we start have the pattern that by having our UI automation test ratio around 50%, our team only need to do less manual regression tests. Then we will have enough confidence that our app is ready to be released. And maybe there's another question that, how about making our UI automation test ratio higher? Like we can have a 70% more, like cover every of our manual regression tests. But after some experience, I believe that we still need to remember what testing pyramid told us. Right now, it's enough for our team. And if we do more, just increase the flaky test result. We only need to make the most important user scenario into our UI test. That will be enough for our team. Next, I would like to talk about our unit test and code coverage. When it comes to code coverage, one question is often asked inside our team: should we write unit tests for UI classes? App is not pure logic application like server side. It need to display user interface. So we have a lot of code bases that need to display our UI. And of course, there's a lot of ways that we can use to only calculate the classes that has logic and business rules. And we don't calculate, we exclude all of the UI classes and we have our code coverage. But is that the real answer for our question? I would like to take this into a more default perspective and to really help our team to how to decide what kind of code coverage we can set the target for our team. And first, I would like to use iOS Xcode as an example. So when we run unit tests in Xcode, we will have code coverage on those classes which responds for like logic or business rules. And obviously, we don't have any code coverage on our UI classes because we didn't write any unit tests for them. However, if you run unit tests in Xcode, you will see code coverage in those UI classes. So it makes sense that in order to have code coverage, you need to write unit tests for those logic and the business rule classes, but also you need to use UI tests to cover all your UI classes. And this concept is not only adapted by Xcode, you can also use Android Studio to prove Android also adapts this concept. I would like to further break down our app. In the app development, like as you know, more like server side and the client side play important roles. So, like a client side, like our app, we need to request data from our server side using API. And then fortunately, or hopefully, we will use MVC pattern to architect our app. And then now we know we can write unit tests to cover all the logic and the business rule classes, like for example, like API client, models, or controller classes. And for the view class, it has no logic. So we can write unit tests to cover it. However, it's not always as perfect. Life is not easy and it's not always be perfect. So let me take iOS as example again. iOS also have an MVC pattern, but it's different from the traditional MVC we know. As many of you already know, iOS has used like a class called UI view controllers to do both tasks of controller and the view. And it's pretty straightforward in small app project, but it will become a big problem in large app project. Because we will end up to have a massive UI view controller class with thousands of code lines. It's painful to maintain, and both logic and business rule code are mixed together with our view code. So for our team, it's even harder to write unit tests to cover them, because everything are mixed together. In order to solve this question, a recent year iOS will start to use new design pattern like MVVM or Viper. Let me take MVVM as example. By using MVVM, we create a class called viewModel to be responsible doing all the logging and the business rule. And then our UI view controllers now belongs to the UI testing field. We don't need to add any logic or business rule code into our UI view controller. By separate logic and the UI we will know for our team what kind of classes we can write unit tests for them and what kind of classes we can cover them with our UI test. So by having this concept, the formula to have good coverage become more clear for our team. We should write unit tests for the classes like, for example, API client, manager, helper, database-related classes. And then for the classes like view, cell, or the classes which handled our animation, we can use UI tests to cover them. And this concept we also not only apply to our iOS Today app, our Android Today app also apply to this concept. So we will generate our code coverage by combining the result of unit tests and our UI tests. And next, I would like to analyze our code bases to see how our team design a good code coverage for our app. So we know now we need to write unit tests, but we also have a lot of code bases for UI, so we also need to write unit tests to cover them. So this is maybe this is the result for our team we need to handle. However, as test experiment and our UI automation test guideline told us, we won't write UI tests for every classes. We only will cover the UI classes that we define in our acceptance criteria. So some part of UI class may not be covered. For example, like arrow display page. Next, we need to remember that our app always will have new code, like new functionality or new UI. So we need to handle that as well. And we did the same thing for our new functionalities because they are logic and business rules. But for our new UI, there are also some part of the code base will not be covered because we don't write every cases into our UI test. Finally, in large app projects, you will always have some code bases that may not be easy to cover, or your team need to extra effort to cover the code base. For example, for our team, maybe we will use some iOS system callback, but it has no clear logic need to be verified. Or maybe our team will have some legacy code that we need to refactor them first if we really want to write unit tests to cover. Because of different situations, or maybe our team are pushed by our business schedule, things are not always be perfect. But now I would like to rearrange the graphic, and I would like to put blue area together and the red area together. And for the blue area, now for our team, it's a code base that our team should be able to cover because we know what kind of classes we can write unit tests and what kind of class we can write UI tests to cover. And for the red area, our team now know is the code bases that may not be easy to cover, and we need to always take that into account. But now, for our team, we can draw a baseline to decide a code coverage target for our team to make sure every time when we change our code, we need to keep our code coverage above this line because there's a reasonable reason and we know how to achieve it, which is the X value you see here. But for our team, we also know that there are some part of code coverage may not be easy to cover in reality. And then it shouldn't be like a really quick decision to say, okay, now we need to have a higher code coverage, and then we set the Y value. It's not a reasonable target for our team. Because as developers, we always need to take account that we need to balance our time between feature development and writing test code. So by analyzing our app code bases, our team have more reasonable target for app code coverage. And most importantly, we know how to achieve it. And of course, as you know, every time when our code will change, like add new code or we're refactoring our code, the code coverage may change. It may goes up or it may goes down. But our team's rule is we need to set out the code coverage that always be above X value when you submit your code. And if your team want to set the code coverage about Y value, it's doable, but maybe you need to think twice how you're going to analyze your code bases and decide your resources to write test code. For the actual numbers of, I think different teams will have different code bases, so you may have a different code coverage target. From my experience in large app projects, if your team are not familiar with test double, like stop, mock, and fake object, or not familiar with TDD, or not familiar with writing UI tests, maybe you can start targeting code coverage around 60%. But the good use of test double and TDD or writing stable UI tests will be really helpful to have your app reach 70% code coverage. Code coverage about 80% is doable, but make sure your team discuss well and analyze your code base first. After having a reliable UI automation test and a solid unit test, I would like to get back to our testing pyramid again. Let's think our test pyramid as a filter that helps us filter issues. Every time when our developers change code, new issues happen. We may have fatal issues that crash our apps. We may have functional issues that destroy our features. We will have UI issues that break our UI. And we also have edge case issues that is maybe out of our app design, but it's still issues. So a solid unit test works as the first layer of the filter. It filters out most of the fatal and functional issues. And integration tests help us to further filter out the remaining functional issues by verifying the interaction of our modules. And our stable and reliable UI automation tests help us to make sure our app is ready in most common and important user scenario. All of us, we can do it by our CI/CD pipeline, and it will provide us quick feedback through our automation system. Before every release, we will perform manual testing to cover the things that our automation cannot cover. So we will have regression tests as well, and also exploratory tests to find any unexpected issue. But now, our team only need to use a small amount of time to do the quick check and to make sure our app is ready, can be released. In conclusion, I would like to recap some of the key takeaways today. I introduced our team's automated CI/CD pipeline for app development and the testing spectrum for our app development. Now our line to the app implement the testing pyramid idea, and now I also want to implement the ideas into my other app projects. Also, I don't think the idea not only can be applied to our app project, I think it can also apply to our web application projects. So some web application project in Line Taiwan, they're adopting our UI automation test guideline to write their web UI automation test. And I think most important thing is the concept or the idea need to be implemented, but you need the support of your team members. I'm really thankful to my team member because when I ask their help, they always answer me yes instead of no. It's a really special team, and I'm really thankful to be part of the team member. I hope you may like my session today, and hopefully it could help you or your teams to solve some of your questions and to have a better development environment. Thank you all today. どうもありがとうございました。